Welcome back. If you're tuning into the channel for the first time, this is another part of my GCSE revision series. This is the final three. These particular final three come from November 2017 paper 3. Now that was a particularly tough paper, so this is well worth your while spending some time on these just to make sure you've got your head straight. Some of the questions I'll do here are similar to other questions I've done on the channel, particularly some of the ones that I did yesterday from June 2017. So again, you can find those on my channel, and if you do have a look at those, or if you're looking at this, I'd really appreciate it if you could leave a like or subscribe, and if you want to leave a comment for future work, and then do so in the comments section below the video. I've also linked to the exam that these come from in the comments section below, so do take a look and just make sure that you've worked your way through these questions in your own time. This first question I'm going to do here, question 19, is a straightforward circle geometry question, but it's asked in a way which throws people. It's talking about proving something algebraically, and that always throws candidates. But what you're going to do is just go through the same process as you always do with algebraic proof or with circles and tangents. So this is the circle here, square root of 20, and here's the tangent line here, x minus 2y equals 10. So we're going to first of all start by writing this as a simple linear equation with x as a subject to the formula, so x is 2y plus 10, and then going to substitute in 2y plus 10 over here in the x squared section. So I'm going to put 2y plus 10 all squared plus y squared equals to 20. So that's what I'm going to work through here. Now 2y plus 10 all squared is going to be 4y squared. 10 times 2 is 20, so that's going to be 20y, and then another 20y, so that makes 40y, and then 10 squared is 100. Okay, so then we're going to rearrange this. So 4y squared plus y squared is 5y squared. We've got 40y, and then 100 take away 20 is 80. That's equal to 0. This is looking now like a quadratic that we can go ahead and solve. You can see that all the numbers here are multiples of 5, so I'm going to divide by 5 straight away. So y squared plus 8y and then plus 16 equals to 0. And we can see this is a repeated root factorization here. So this is y plus 4 squared, and this is the key that unlocks the problem. The fact that we know that that's a double root is telling you that this is actually a tangent problem. So I'll explain why in a minute, but let's first of all get our values. So y is minus 4, and then from earlier, if you use y is minus 4 in this problem here, so 2 lots of minus 4 is minus 8, and minus 8 plus 10 is 2. I've got my coordinate point 2 minus 4. So picture in this problem, here's the problem, here's a circle, radius root 20, here's minus root 20. We can see that this particular line is going to hit it where x is 2 and then y is minus 4, so somewhere about there. Okay, so this is how the problem looks in actuality. The fact that it only hits it once means it has to be a tangent. If it hit the circle and it wasn't a tangent, if it hit the circle somewhere else and hit it, it would always hit it twice. If it went through the circle like here, it would hit it twice. If it didn't hit the circle at all, there'd be no solutions. If it went through the circle any other way, there'd always be 2 solutions unless it was a tangent and it only hit it once. So the fact that that is a repeated root implies that it is a tangent to the curve. We must just state that. So we're just going to say that it's one solution, so therefore it's a tangent. So we're just making that little statement there at the end just to make sure that we've got that understood and clarified, and that's our 5 marks got for this question. As I said, this particular paper was quite challenging. There are some other quite challenging questions on this. Question 20 I've actually started that earlier. Just to show you how it works, but I need to get some pre stuff done, so I'm having a look at this with you here. So this question is quite interesting because it's talking about the points and circumference of a circle. It's absolutely specifically telling you not to do circle theorems. You must not use circle theorems. And my major hint for these sorts of questions is to go through and just identify lines to draw. So sometimes you're going to draw lines which make it cyclic quadrilaterals. Sometimes you're going to draw lines which are tangents. But in this situation, you're drawing a line that goes from O to C. So that's what I started with here. And that creates for yourself 2 isosceles triangles, an isosceles triangle OAC and an isosceles triangle OCB. Now, because these are isosceles triangles, I've also corresponded these, or got these angles down here, x and y. So I'm writing down here 180 is x plus y because we know these are on a straight line. The angle in the corners here will be 180 minus this divided by 2. So 180 minus x divided by 2, that's the angle OCA. And the angle OCB will be 180 minus y divided by 2. Now, how does that help you? Because we've done the little triangles, the two little triangles here side by side. What we're now going to look at is the big triangle ACB. Because what we're being asked for is this angle in this corner. Now, I know from angles in a triangle that this one plus that one plus this one must make 180 degrees. So the strategy that's going to unlock this problem is to do 180 degrees, take away this, and then take away that. Okay, so 180 take away these two things, add it up, and then that must make this one. So that's the strategy that unlocks this problem. So I'm going to write an expression here. I hope you understand it. But the angle ACB here, that's the angle in that corner up there, just pointing it out to you, is 180. Now it's going to be minus these two corner angles. So this angle here, which we said earlier was 180 minus x divided by 2, added to the 180 minus y divided by 2. That's the angle in the other corner, this angle here. It's going to be minus those two things added up. Now these two things added up make 360, and then I've got minus x plus y, so be careful about your signs here. It's a common denominator, so I can put it over the same denominator, so be careful how I'm writing this here. I've written it as minus brackets x plus y. I've done that for a particular reason, you'll see why in a moment. And they've got 180 minus this. Now this x plus y, earlier on we said that x plus y was 180. So I'm going to say here that this is 180. So I've got now 180 minus 360 minus 180 over 2. And you can hopefully see what's going to happen now. So I've got 180 here, divided by 2 is 90. So I've got 180 minus 90. And that indeed is 90. And so I have proved that the angle ACB is 90 degrees, which is what I was asked to prove in this particular question. Quite a testy question, quite a lot to get through. Lots of stuff that you might not necessarily think of under pressure, so a tough question and a tough 4 marks. The last question is the hardest one of all. I think over all 3 papers, this is the one that I didn't like at all. So this is really quite difficult to do. Quite a lot of construction to do here. It's a vectors question which looks a lot easier than it actually is. It's much, much more difficult than it looks. But there are some things that you can write, and my key moral here is to try and write everything you can. So if you're going for an 8 or a 9, you won't need to have perfect scores. You just need sort of around 80 or 90% in these exams. Okay, and that is doable if you're just writing stuff down, particularly for these last 3 questions. So these last 3 questions, you don't need 100%, but if you're getting a lot of it right, you will get a lot of credit. So I would always suggest to write things down. Now in this particular question, they are telling you some things. So OA is, for example, they're telling you is A. And then they're telling you that OB, this whole lot, is B. And they're saying things like that M is the midpoint of OB. And they're saying that there's some scalar quantity K, so it's dividing this particular thing. So it'd be nice to know what AB is, because they're mentioning it in the question. So my first step is to work out what AB, or get an expression for AB. That's really easy because it's minus A plus B. So that's already going to get you a mark. Okay, out of the 5 marks, that's already 1, I'd imagine. Now, the next thing is to talk about why this is a straight line. It's a straight line, which means that actually, if you're looking at my construction, the line that goes from there to there and the line that goes from there to there are going to be some multiples of each other. So this line that goes from N to M is some multiple of the line that goes from N to P. Sorry, I need to show you that. Didn't show you that very well. I'll just do that again. Sorry. The line that goes from N to M is a multiple of the line that goes from N to P. That's what it means that they're on the same straight line. They tell you it's on the same straight line, and that's a fact. These two things must be multiples of each other. And that is a strategy that unlocks this particular problem. So we're going to write down a vector for N to M. Again, marks for this. Just for writing this, you're going to get marks. So N to M. Now there are some things that the question tells you. For example, in the question it tells you that this is 2 lots of this distance, so I know this vector must be 2a. And we're going to go from N to M, so that's minus 3a plus half of b, because M is the midpoint. So it's minus 3a plus half of b. Again, marks for this, I'm sure, just for doing this. We're now going to write a vector expression for N to P. So that's this bit here, so from there to there, N to P. So N to P, what's that? Well, it's going to be, well, it's minus 2a again. It starts in the same way. So minus 2a from there to there. Just show you that real quick. So minus 2a. And then the k multiple, the k multiple of ab. So to get from a to p is going to be k lots of this vector that we wrote earlier, minus a plus b, this vector from here. So that's how you get from n to p. So it's quite a fiddly little thing. Now, let's have a look and see what's going on with my a part. My a part here, if you look at it carefully, is going to be minus 2 minus k. Okay, so if I write it out in terms of its components, I've got minus 2 minus k, and then I've got k lots of b. Okay, now I know that this is some multiple of this, okay, because they have to be. So I know that because one is both straight lines, they're both going through it, minus 3 is some multiple, let's call it lambda, of minus 2 minus k. I know it's some multiple of that. But I also know that the same multiple is going to be, so half is going to be that same multiple, that same lambda, of the b coordinate, so the b vector, so the b vector is k here. Now I can write an expression here for lambda. Lambda is going to be equal to 1 over 2k, and I'm going to use that as a substitution in this particular problem here. If I do that, the whole thing falls apart. So 1 over 2k minus 2 minus k, and now I'm going to solve this. Again, this is without a calculator, I think. Oh no, sorry, this is paper 3, so this is with a calculator, but this is quite dodgy, quite hard to do, get your head around, but hopefully you can see what's going to happen here really quickly if I take my time with it. So I'm multiplying up my brackets here. I'm taking my time a bit just because I want to get this right. I don't want to make a mistake. So you get that real quick. So you can see the k's are going to cancel. I'm left with minus 2 over 2k there. So again, working your way through, you're going to get a very quick problem. So I've got minus 3. This is going to be minus a half here. So going to be plus a half over here. And then I've got minus 1 over k. So minus 3 plus a half is minus 1 over k. Now that's minus 2.5 or minus 5 over 2. And that's minus 1 over k, which means that k has to be 2/5. Okay, so k is 2/5. That's a very, very difficult question. Lots of work, lots of thinking had to happen to get this 5 marks. But as I said earlier, even if you can't get the 2/5, if you can at least write vectors for nm and maybe get a vector for np and maybe get this bit out, you probably get 3 out of the 5 or 2 out of the 5 marks, and that's well worth doing. That's the end of the video for this one. And reminder again, this was November 2017 and that was paper 3. I wish you all the best for your summer exams if you're in revision, and hopefully I will see you soon. Okay, goodbye for now. Bye-bye.